Morning, guys. My name is Bulelani Mahwanana, and welcome to Math Sessions with Mr. M, which is me. So I want you to stay tuned. Today we are doing linear number patterns, grade 11. So now I want you to take note here as we are going further. Let's say you are given the infinite linear pattern, which is 12, 17, 22, which is the other term is 172. So I want you to be very careful on this one, because now a linear number pattern has a number between 1, 2, 3 terms that is constant. It's a constant number which must take note of. So here we have 12, 17, and 22. So when you subtract the second term from the first one, there must be a number that is the same when you subtract the third term from the second one, as given in grade 10. So when you subtract here 17 minus 12, you get 5. 22 minus 17, you get still 5. So these are very important keys when it comes to linear patterns. So this is our given pattern here. Okay, let's see what we can do with this. Let's see what we can do with this one, because now it's very first question, they say determine a formula for the nth term of the pattern. Get the question? Determine the nth term of the pattern. Okay, when we draw it down, as I explained to you, that between these three patterns, there is a constant number in between of them before you can answer that question. We have 12, 17, and 22. So there is 5, there is 5. This is what we're talking about. So these are important keys on patterns. So, okay, we are going to determine an nth term of the pattern. Number 1, you must be able to identify your general formula of linear patterns. And this is your general formula. This one you must know by heart. This is your general formula of your linear pattern. So now we are going to begin to take and break this to determine our nth term of the pattern. So now what else is here? Okay, this is our formula. This is our formula, and we know it. So we are going to what you see here is numbers being taken from what you were given. Let's move a little bit backwards so that I can explain to you these things. Because we understand, according to linear patterns, the first term, which is 12, it becomes your A. Your 5, which is constant between these three numbers, becomes your D. According to your general formula, which is this one. This is your A and your D, which is why you get something like this when we have substituted the numbers inside and you work out. So your general term becomes Dn is equal to 5n plus 7. So that is your general term. That is a very straightforward one. Okay? Okay, let us move to the next one. Let's say they say to you, calculate now the value of the 12th term of the pattern. You know your pattern very well. You know the general term. You just substituted it, am I now? So now they want you to calculate the value of the 12th term. Take note of how they ask the questions. They say of T12. You know that in your general formula you have Tn is equal to 5n plus 17. So that is your general term. So you know now you are going to calculate, you are going to in fact substitute number 12 into n so that you can know what is T12. Right straight to what you calculated here, because let's move a little bit back. You see, this is the end term of the formula. So when they say T12, they say this 12 is substituted here and there, and then you work out. So what do we get? This is what I'm talking about. There's the general formula. Tn is equal to 5n plus 7. So they say, give us the 12th term now. Give us the 12th term. You are going to substitute 12 here on this end. And you are going to multiply 5 multiplied by 12 plus 7. And then you'll be getting your answer. This is what I'm talking about. So you have substituted now your n, you have replaced your n with a 12. Because we want the 12th term. We want the 12th term. So it becomes now 512 plus 7. So our answer will multiply 12 plus 5 plus 7 gives us 67. So these are the little things when it comes to linear patterns. Let us move a little bit further. They say to you, determine now the number of terms in the pattern. Look at this one very carefully. It's not the same as the previous one. They say the number of terms that are in the pattern, not a certain pattern, which they are, they said, the 12th term. They are not specific. They want the number of terms that are in that pattern. Okay. Let us look at our general formula. There's our general formula. There's our n term. In fact, we know our n term. Our n term is Dn is equal to 5n plus 7. So we work out by our n term all the way through. So if you get your n term wrong at the top, and everything that follows, it goes wrong. So you must be very, very, very careful. Now, they say, we want now you to tell us the number of terms that are in this pattern. To remember what we are given 4 numbers. So, what they are basically asking for is this here, this n, which you do not know, the number of terms. So, I want also to be careful on this one when you calculate n, that whenever you get a negative or a fraction as an answer for n, you must know there is something that you did wrong. Right here, this is a basic of n. N is a positive integer. You must know that. Once you get a positive n, a negative n or a fraction, you must know you have done something wrong somewhere. You have done something wrong. So what we are going to do, we are going to substitute our last term here on this Tn, which is 172. Our last term is 172. It's the same as, the n term is the same. We just want n. And then we work out to get our n right there. So we take this 7, we send it to the other side, it becomes negative. And it subtracts from 172, and it gives us 165. So we have 5n is equal to 165. 165. 5n is equal to 165. So now we understand now from here that if you want to get 5n, if you want the value of n, you are going to take away this 5. So you are going to divide by 5. What you do on the left hand side, you do also on the right hand side. You divide by 5. Then your n becomes 33, mathematically. So you have now discovered the number of terms that are in the sequence. There are 33 numbers that are in this sequence. Okay, let's say you ask, and they are we are basically done with that pattern now. It was very straightforward, that one. Now I want to show you also the pattern that involves values that you do not know. In fact, this one is a linear pattern. They tell you, they say you have 3, you have x, you have y, and you have 30. So there are values that you do not know that are in this pattern. And now it becomes a bit tricky now because you do not know. You do not know the middle terms, which is x and y, between these four terms. There are four terms here. Let's say, given the first four terms of a linear pattern, which is x, y, and 30. Okay? They say, calculate for us the values of this x and this y. Now it gets a little bit frustrating now because you do not know this. But I do not want you to get frustrated. Listen to me very carefully. According to your linear pattern rule, finding a difference between terms, you know that the second term, it subtracts from the first term to get the difference. The third term subtracts from the second term to get a difference. The fourth term subtracts from the third term to get a difference. Do not mind this one here. This 30 must be up on this side and this y on the other side. So this difference, these must be the same when you have found the values. Okay, what can we do? We use the difference formula. The first term, which is x subtracted from 3, is equal to the third term subtracted from the second term. This is a distance formula. Okay? What can we do here? What can we do here? What can we do here? This is what we do. We make y the subject of the formula. Do you see what I did right there? Let me move a little bit back. You take this x, you send it to that x, it becomes positive, 2x. So y is equal to 2x minus 3. So, which is what you have right here. Your y is equal to 2x minus 3. So, we made now here y the subject of the formula. We made y the subject of the formula. Okay, we want our y and x. And also now what we did, we took the first term and the fourth and the third term, which is the same thing when you are calculating a difference formula. So it's the second term subtracted by the first term, and the fourth term subtracted by the third term. Do you see it now? So it's x minus 3 is equal to 30 minus y, because now we want to find also, we want to know also what is our x. Okay, we already know what is our y. Y is equal to 2x minus 3, right? So we are going to take this value of y, which is 2x minus 3, we are going to substitute in this difference formula of y. We know our y. Our y is 2x plus 3. So there's our substitution. So we have similar terms now on this equation. X minus 3 is equal to 30 minus 2x plus 3. So now, what do we do? We subtract, we add common terms. So when you have done that, you're going to have 3x is equal to 36. So from here it becomes more easily now. You are going to take away that 3, you are going to divide by 3. What you do on this left hand side, you also do on the right hand side. You divide by 3. Then your x becomes 12. So you know your y and you know your x. Your y is equal to 2x minus 3. Right? And your x is equal to 12. Your x is 12. You are going to take that 12, which is x, and you are going to substitute it here on this y equation, which is y is equal to 2x minus 3. So there's going to be a 12 there, which is 2 times 12 is 24 minus 3, which is going to give you 21. There's your y. So you have your x, which is 12, and your y, which is 21. So there's your answers. X is equal to 12 and your y is equal to 21. So that is basically the linear pattern for grade 11. For our next session, we are going to touch the quadratic equation, which is more expanded from this one. So now you are basically going to face these kinds of questions coming during exam. So you must be ready for these things. For today, that's all. I want you to stay tuned. On Friday, we are going to touch for grade 10s. And also, I want you to like my page, Math Sessions with Mr. M. So, linear patterns for today. Have a great day. Bye-bye. Enjoy.